Everybody has the notes from yesterday then? All right, so we're gonna do our last day on proofs today. And then tomorrow we switch over to something completely different. And then, at this point, I don't think I asked you guys this yesterday. I think I asked my 4th hour. But we're not quite going to be done with chapter 2 next week to test before break. But at the same time, I'm worried if you have a 5 or 4 day break and then come back and do a section or 2 and then take a test, is that too hard? What do you guys think? Or would you rather have me stop on Monday where I'm teaching, do a practice quiz on Tuesday, quiz on Wednesday, and then continue after break?
I'll just go after break. We can just do the test next week. No. Yeah, it will come back in your grades. Just.
How many of you would rather get the quiz out of the way next Wednesday?
How about Tuesday?
Yeah.
I'll do it Tuesday.
How many would rather wait till after break? Okay. So I'll talk again with my 2nd hour, or not 2nd hour, 4th hour, and decide, and I'll let you guys know. For me, actually, it would be better to do it after, just because that weekend, next weekend is my son's wedding, so I don't know when I ever get to grade them. So, like, then I'd feel bad, but we'll see. I'll see what happened with when I talk to them. Okay, so today what we're gonna do is the 2nd day of section 2.6, and this is gonna be more proof oriented. So a lot of times with proofs, when they introduce something new, which they introduced angles, and the fact that angles are congruent, they'll talk about reflexive, symmetric, and transitive. And reflexive property just says something is congruent to itself. Symmetric is when it flips around, just like we learned before. And transitive, again, is when the ending of this and the beginning of that are the same, and then you cross those out and the outside two are the same. So that is true of angle congruence as well as other things that we've talked about so far this year. So these two theorems, when you hear them, sound confusing, but I'll try to put it in simpler terms. So what this says is it's called the congruent supplements theorem, and it says angles supplementary to the same angle or two congruent angles are congruent. And that kind of sounds kind of confusing, but here's what it's saying. If you have an angle like angle 2 here, and let's say it's 70 degrees, and let's say these two angles are both supplementary to this angle. What does supplementary mean again? 180, right? So if these two are supplementary, do you get this would have to be 110? And if these two are supplementary, wouldn't this have to be 110? So what this is saying is if you have two separate angles supplementary to the same angle, the only way that would happen is if these two are equal. That's what it's saying. We'll prove this theorem in the next slide or two, but it's not something we use a ton, but we will prove it. If you look here, this is exactly the same theorem as this, except this one's talking about congruent. So say that I told you this was 50, and I told you these two were both separately complementary to this 50-degree angle. If these two were complementary, this would have to be 40. If these two were complementary, this would have to be 40. So for two angles to be complementary to the same angle, the only way it happens is if those are equal. So in geometry, sometimes they will give you a theorem and then they'll ask you to prove it. Okay, so that's what this is. So they're giving us two different givens. So for step one, we're going to say given. Okay. And so what they're telling us here is these two are complementary and these two are complementary. And we want to prove that these two then would be congruent. Okay. So when I go to do this, there is going to be a step here that we haven't talked about yet, but it's also a step we only use in this proof, so you don't really have to worry too much about it. But do you guys get it if they tell us that two angles are complementary, that their measures would add up to 90? That is definition of complementary angles. But like I said, this is the only time they use that. Okay. And then they also say because angle 2 and 3 are complementary, their measures add up to 90. Then what we have to do is try to figure out how they got step 3. Okay. Do you see how this equals 90 as well as this equals 90? Do you remember me saying if these two sides of two equations are equal, doesn't that make those two equal? All right. Basically, what they did here is, so if you did this with a, yeah, what they did is because this is 90, the pink box equals 90, they picked that 90 out and they put the pink box in there. That's basically what they did. Because this is 90 and there's a 90 there, they picked this out and put it in there. So what would that be called? Substitution property. Very good. Then, can you see what they would do to get from here to here? Subtraction. And we remember with subtraction, you're going to go SUBTR prop. Okay. Then, if you look from here to here, they drop the M's and add the squiggly. Do you remember what that was called? Yes. Very good. All right. So let's look at this. And this is proving the second theorem that we learned that said, if you have two angles that are, this one is a little bit different. It's saying these two are supplementary. These two are supplementary. These two are congruent. And they want us to prove that these two are congruent. Now, I would never have you do this proof on your own, but with the steps out like that, it's not too bad. So here, notice we're given 3 different things, okay? And I put all 3 of them under step 1, so this would be given. Now, do you see how angle 1 and 2 are supplementary and 3 and 4 are supplementary? Do you get that because of that, you could say their measures add up to 180? Do you know what that's called? Do you remember how this proof, when they said the measures add up to 90, was definition of complementary angles? So this would be definition of supplementary angles. Now, if you look here, notice that this equals 180 as well as this does, okay? Because this pink box equals 180, I can pick this one out and put this in there. And that's what they did to get to here. So what is that called? substitution. Now, this is a little bit harder than the one we just did. The last one, we were able to subtract right away. But if you notice this one, there's nothing to subtract away. All of these are different. Okay? But note from here to here. What did they do with this to get this? Took out the squiggly and added the little m's. That is called what? Congruent, you're really close. Congruent angles. Very good. Right? Now that we have that, like I was telling you guys, I always look back at like, what am I trying to prove? And I'm trying to prove that 2 and 3 are equal or congruent. Okay? I want these two or these two to be equal. And how I could do that is if I got these two to be the same, so you can subtract them away. So the measure of angle 1 equals the measure of angle 4. If that's the case, do you guys get that I could pick the measure of angle 4 out of here and substitute in the measure of angle 1 for that? So that's basically what they did. They're trying to get this to be equal. These two are equal, so if I pick this out, I can put angle 1 in there. That is called substitution property. And the reason I would do that is now I have a measure of angle 1 on both sides. If you look right here, now we have a measure of angle 1 on both sides. So we can get rid of that by doing what? Subtraction. Very good. And what do you call it when you take the little m's off and add the squiggly? Very good. Definition of congruent angles. Okay. Now, let's look here. And this deals with vertical angles. This is a theorem that we talked about earlier, so this isn't new. Vertical angles, if two angles are vertical, they are congruent. So remember, vertical angles are anytime you have intersecting lines, they're the angles across from one another. Okay. So 2 and 4 are congruent and 1 and 3 are congruent. Okay, that's what this says. If you ever use that in a proof, your reason would be vertical angles theorem because it has a special name. So if you have a theorem that ever has a special name, a lot of times you'll use that for a proof. So now we're going to do a proof with vertical angles. And I'm not sure how much, if I've said this much at all, but if you ever have an if-then proof, the if part is the given, the then part is the proof. So it says here that we're given angle 1 and 2 are vertical angles. And I use VERT for angles and then my little angle symbol, or for vertical angles, that's how I'd write it. They also give us that the measure of angle 1 is D minus 32, and the measure of angle 2 is 175 minus 2D. And what they want us to prove is that D equals 69. So this one is kind of a geometry and algebra proof together. Okay, starts out where we are going to have geometry, but then it'll switch into a algebra proof. So the first thing I'm going to do, I'm going to write all 3 of these under one given. Now, I have my given down, and what I'm going to do is I have to do something with the fact that these are vertical. So I am going to use the vertical angles theorem that says if two angles are vertical, they're congruent. So what I can say then for step 2 is since angle 1 and 2 are vertical, they're going to be congruent. So I'm going to say angle 1 is congruent to angle 2. I can't say they're equal because the theorem says they're congruent. So I have to say congruent. And that is by the vertical angles. And for theorem, I always do THM. Okay, so that's vertical angles theorem. Now, eventually what I want is I want to be able to substitute this in for angle 1 and this in for angle 2. But to do that, I need to get rid of this squiggly and add the little m's. So what I'm going to say then is the measure of angle 1 equals the measure of angle 2. So I took the squiggly off and I added the little m's, and that is what? Very good. Definition of congruent angles. Now that I have that, now I can take this d minus 32 and substitute that in for angle 1. And I can take the 175 minus 2d and substitute that in for angle 2. Okay. So what I would get there then is d minus 32 equals 175 minus 2d. Okay. So what I would get there, I took that out and put something else in. That is substitution property. Okay. I took angle 1 out, put d minus 32 in, and the same with angle 2. Now I'm back to where I have an algebra proof, and I just have to solve for d. So what I would do is bring this minus 2d, I'd bring that over here. And do you guys get we'd add 2d, right, to get that over there? So if I added 2d to this, I'd get 3d minus 32 equals 175. And like I said, we added 2d, so this would be addition product. Okay. The next thing we're going to do is we would get rid of this minus 32 by adding 32. And when I add 32 there, I would get 207. Okay. I added 32 to both sides, so that is again addition property. And then what I would do is divide by 3. And then I would get what I am supposed to looking up here. And I divided by 3, so that is division property. So that one's kind of a combination geometry algebra proof. So we have 2 more proofs. This one is dealing with an angle bisector, and I don't know how much we've talked about an angle bisector, if at all. But an angle bisector would be an angle that cuts an angle, or I'm sorry, a ray that cuts an angle in half. So if this was a 60-degree angle, this ray would split it in half, and each of these would be curved. That's what an angle bisector is. Okay. And what they tell us here is that BX bisects angle WBY and BY bisects angle XBZ. So let's go ahead and write the givens down. So ray VX bisects. You can use BIS for bisects. Angle WBY and BY bisects angle XBC. Okay. Now I'm gonna think about what is an angle bisector. And an angle bisector bisects something in half. Okay. So they tell me here that our array VX bisects angle WBY. So that means this and this are congruent. Okay, those two. Now, this is one thing that is not super ideal, but when you name these angles, you like this one, you can name WBX or XBW, and they're both the same. But when you name that, you want to make sure the way you name it is the way they did. So if you look, WBX is right here, and that is how they named it. When I name it here, I'm going to say WBX, angle WBX is congruent to angle. Now this one can be XBY or YBX. And if you look at the four they have here, that is not one that they have there. So I'm going to just say XBY. Now, this is a step we have not talked about yet, but if something bisects an angle and you say those two parts are congruent, that is called definition of angle bisector. So I just use the angle for the word angle and BIS for bisector. Okay. Now, it also tells me that BY bisects angle XBC. So that would mean that this angle and this angle are equal. So I have to name these two and say they're congruent. Now, this angle I just named right here. So when I name that one, I have to name it in the same order that I did. So I'm going to say angle XBY is congruent to, and then this angle, notice I could say YBZ, which is actually how they did it, or I could say ZBY. And they said YBC, YBC, so I'm going to leave it like that. Okay. Then, if we go to our next step, here's where I have to decide, what do I have to do? Okay. So notice what they want. They want that this is congruent to this. They want that these two are congruent. Is there anything we know that we could say that right now? Transitive, right? This and this are the same, so you can cross those two out and say angle WBX is congruent to YBZ. So it's like this and this can cross out because of transitive, and you say those two are equal, and that's by transitive property. And that is what we want, so we're done. Now let's go to this last one. And again, we have a given, so let's start there and do angle QPS is congruent to angle TPR, and that is given. Now, with these angle proofs, if you ever get stuck, maybe this is something I should write out. And you could add this if you have room on your cheat sheet, add this. If you get stuck on angle proof, And where I would add this, you guys, is right by this in your notes. Probably add it right below. I think I'll do that. Okay, so if you get stuck on angle number 1, take the squiggly off and add M's. And the M's are for measure. So that's one thing you can always do. Okay. The second thing we would do is we would use angle addition postulate. So let's say break angle up into parts. Using angle addition postulate. What that means, just so you know, that would be where you'd say this whole angle equals this angle plus that. That's what that means. Once you get to that point, then you're gonna look at your proof statement and start using substitution to try to get to it. So that's what you do. We also had some steps for what do you do if you get stuck on a segment group. This is when you get stuck on an angle. Did you all get a chance? So let's go to this. And let's go back. Okay, so here, notice what they did, and this is why I tell you guys, whenever you do a proof, write the given, write the proof. The diagram is the most important part of a proof or a geometry proof. So it's saying angle QPS, which is this whole thing, equals angle QPR, which is this, plus RPS, which is that. So what they did there is they took that angle and broke it up into parts, and that is angle addition postulate. Just like we did when we took a segment and broke that into parts, that was called segment addition postulate. Okay. Then okay, so then in that same step, they took angle TPR, which is this angle, and they said that is equal to angle TPS, which is here, plus angle RPS, which is here. Okay, so they split that one up into parts. So now what I would do is that both is angle addition postulate. Then I have to figure out how did they get this step? And a lot of you would move back to this and you would look at this and try to figure out how they got it. But in actuality, this one goes back to our given. And didn't they just take the squiggly off of this and add the little m's? What is that called? definition of congruent angles. Then, if I look, they are telling us here that this and this are equal. Okay, notice this is this, and this is this. And remember what I told you? You ever notice these two sides are equal? What do you know about those two? They're equal. Okay, basically what you could do here, if you don't notice that, QPS is this. So you could pick out this QPS and put this pink box right here. And then TPR is this. So you can pick out TPR and put that right there. And that's basically what they did there. So when I write that, I have to write kind of small. So the measure of angle QPR plus the measure of angle RPS equals the measure of angle TPS plus the measure of angle RPS. Okay. So that's substitution. It really should say property here. Now, if you always kind of look back at like, what are we trying to prove? We want that QPR, which is right here, is congruent to TPS, which is right here. Can we get those two by themselves? Because these two, what can I do? Subtract, right? Because they're exactly the same. I can subtract them away. So I'm going to say the measure of angle QPR equals the measure of angle TPS, and that is subtraction. We should not ever math books out, you guys. Teaching. So that's subtraction property. Okay. And then if you look what we want, the only thing that I have left to do is take the little m's off and add the squiggly. So that is QPR is congruent to TPS, and that's definition of congruent angles. So your assignment today is partly. So this is a worksheet that I am giving you. And these problems are in the book. So this is 31, 32, 33, 34, 35, 36, 37, 38, 38. Oh, this could be 4, 5, 6, 7, 8, 9 plus 14. So what is that? So the worksheet problems are on here. The rest is in your book. So you'll do that on your homework paper or just notebook paper. And please, please, please staple those together. When there's two assignments, I always want to staple. And there's a stapler on the desk.
Oh, thank you.
Yeah.